In this video, we are going to talk about dynamics. With dynamics over there, dynamics is basically branch of mechanics in which we study motion with discussing its cause. Means what is the reason for any speed, acceleration, how much force is applied, like branch of mechanics, branch of mechanics in which we study motion motion with discussing its cause. Its cause over there. This is called dynamics. The main key factor of dynamics that to know what is the reason why the body is moving in any direction with any mass or acceleration over there, we will have to take basic phenomenon that is called a force. Force is a push or a pull, and the rate of change of momentum. I will explain this later that what is the rate of change of momentum. But right now you can say force is a push or a pull. Force can change the position of a body. Force can change the shape of a body. Force can change the direction of motion of a body over there. That is called a force. Force is a vector quantity. It is measured in newtons. It can also be written as kg meter per second square as its SI base units over there. Otherwise, its SI unit is taken as Newton. Tension force appears away from the point towards the middle of the rope. Like tension which the boys are exerting the applied force in this direction, tension is coming and shown at this position in the form of a strength towards the center, and applied force by these boys is being exerted, and this is the point of action of a force shown over there in red color as a dot, and tension is again produced towards the center. This is the center point, and inward pull and toward pull will be called as when someone is pulling as a tug of war over there. Tug of war. And compression force acts always outward. When you are compressing someone, means for example you are pressing a spring, you are pressing any elastic body which can be pressed over there, then the force will also be towards the point, like outward pull will be given with the help of compression force tracks over there. Like he is exerting the force P in this direction and compression is exerting force in this direction, that will be outward pull. If you want to pull outward, then you will have to push in the form of compressions over there. Here I said that force is a vector quantity, then I will say vector means a vector which has some direction and according to length have some magnitude. When I take two or more forces in the same direction, and then I will say the forces will add up and will give me the larger magnitude resultant vector over there. If I am saying the main vector is present in F, here I am also mentioning the names over there. Thus this is the force 1, this is the force 2, where I am saying the third one is force 1 plus force 2. On the other hand, when I am taking this and this in black color only, just look in the black color only, I am changing the direction over there. What will be the resultant over there? Resultant only will be in this direction as a resultant. Let's suppose I say this is the 7 Newton and it is 4 Newton, then 4 Newton is subtracted and you are getting 3 Newton's force as a resultant only over there. After that, we will also have to know about the Pythagoras theorem, that if x-axis the force is acting along this, then its components can be taken in the form of resultant, like this is fx, this is fy, and you can also take the force in the form of resultant over there. Then you will have to take fx and fy is here, fx is here. According to Pythagoras theorem, if you want to go for calculation of magnitude, then you take fx square plus fy square, On the other hand, if you are going for the direction of the force over there, then you use tan inverse Fy over Fx over there to be taken into account. After that, he is going towards Newton's laws of motion. Basically, there are three Newton's laws of motion are available, which govern the movement of the bodies under the umbrella of Newton in mechanics. All right. Newton's first law. Newton's first law states, for example, there is a body which is at rest, lying at any position. It will continue its this position of rest or moving with a constant velocity, moving with a constant acceleration like that. It will continue until no external force is applied on it. An object continues in state of rest or motion or uniform motion unless acted upon by a resultant force. Means some external force is going to act on that body. That is called Newton's first law of motion over there. Newton's first law is also called as law of inertia. Law of inertia. Inertia is a property of body which depends upon mass of body. Like as for example, I say there is a truck moving with speed of 20 meter per second, and you want to stop it by your hand. It is impossible. On the other hand, the bicycle is coming bicycle of the smaller mass is coming with the same speed of 20 meter per second, and you want to stop it. For example, some danger is present and you are standing in front of it, and some baby boy is driving the bicycle. You want to stop it, even though you will little bit get hurt, but you can easily stop the bicycle over there and you can save the boy over there. So that not able to stop over there because of just big mass of truck means when the mass is larger, then you can say inertia is larger. So inertia is a property of body which due to which it resists any change in its state of rest or motion over there. So the same Newton first law is also being called as over there. After that, he is talking about Newton's first law of motion, as he said that body continues in state of rest or motion over there. He is showing some of all the forces acting on a body is equal to zero. Then we can say body is at rest. Forward force is equal to backward force like 5 plus 10, 15. And this is 15. Body is at rest over there. On the other hand, 600 Newton and 1000 Newton is being taken over there in this direction. Then 400 Newton towards the right, the body will start continue even though when both net forces are acting over there. When I am saying that backward force is being acting like 600 and 400 should be backward if body is at rest over there then being taken. For example, you are applying 600 Newton, 1000 Newton you are applying. With 400 you are moving and 600 is being lost with the help of friction over there. At rest speed is zero. It will not move. If it was already at rest, it will not move over there. It will continue its state of rest or motion, uniform motion at constant speed, straight line. It will keep on moving at a constant speed in a straight line if it was already in motion. Like in fifth gear, the car is not getting too much consumption of the fuel because he is just maintaining the external resistance, and that is called uniform motion. There is no external force needed to affecting to accelerate the mass of that body according to Newton's first law. After that, we will have to also observe what is the resultant force is zero means that sum of all the forces like F2, F3, F4, F5, F6, these are lying, for example, a balloon lying on the surface of Earth. So right, left, when balloon is at rest, then the force exerted by the air particles which are striking with the balloon is at rest, then we say sum of all the forces is equal to zero. And in case of resultant forces, like he is saying removed resultant force is being taken into account, then if one of the forces gets removed means you have removed some any force, then the resultant force will get damaged and the system moves in opposite direction to so that he can balance that. So resultant force will equal to F2, which is exactly opposite in that direction. For example, for balancing, you were providing a force over there and you remove that force. Then what will happen? It will start to move in opposite direction of that force which you have removed to balance that over there. Examples he has taken, like he is saying, if left-wise is 18 Newton, right-wise 10 plus 8 should be there as Newton over there. And if it is 20 plus 30, 50 above, 25 plus 10 is 35. So Y should be 15 over there. So that 50 Newton upward and 50 Newton downward can balance the force of forces acting on according to the formula sections over there. This was Newton's first law. On the other hand, he is saying two conditions of equilibrium. Two conditions of equilibrium states that if somebody is at in equilibrium, then what will happen? To be a balanced state, not to change the state of motion like that. Condition one, sum of all the forces must equal to zero. Sum of all the forces must equal to zero, and sum of all the moments. Moment is turning effect of the forces for rotation responsible over there. Summation should equal to zero over there. So this is for balanced body at rest or body is moving with uniform motion. Both conditions should be taken so that body could be taken in equilibrium over there. After that, he is saying that what is Newton's second law of motion? According to Newton's second law of motion, I will simply say here, let's suppose there is a body which is having mass m, is moving in the direction of acceleration a. When a force F is applied in the same direction over there, then this produced acceleration will be directly proportional to applied force and inversely proportional to mass of that body. And for removing this proportional sign, we introduce A is equal to kF over m. And if I take 1 Newton, 1 kg, 1 meter per second square, then K I will get 1 over there, and it will become A is equal to F over m, which I can write as F is equal to ma. This is a little bit explanation of Newton's second law. And in the start, when I wrote the unit of force as Newton, also I have written kg meter per second square. Kg is taken from mass and acceleration is giving me meter per second square. I have given the unit of force over there. Here he is saying for Newton's second law can also be stated in this format, that the rate of change of momentum is directly proportional to the resultant force over there. Which he is saying basically force is directly proportional to mv minus mu over t. Rate of change of momentum means change of momentum is above with respect to time. You will say it is the rate of change of momentum is directly proportional to applied force. Again, 1 meter per second, 1 second, 1 Newton force, then F is equal to mv minus mu over t can be taken into account. So another, when an object experiences a resultant force, it accelerates in the direction of result force, means a Newton law can also be stated in this format over there. Here he is saying that remember that there needs net force acting on a body to produce a change in motion. If the resultant force turns out to be zero, then the object will continue state of equilibrium. The opposing force produced in the body during motion is usually taken as applied force or acting force. The driving force of the body is cancelled by these forces and always act in opposite direction of the motion over there. Okay, so he is saying net force is equal to forward force minus backward force. Means this is MA force. This is your applied force with the help of engine. This is your resistive force or normal reaction force, which should be subtracted in the form of resistance or force of friction over there. Then you will say accelerating force will equal to applied force minus force of friction over there. As like he is saying 10 Newton towards right, 6 Newton towards left, it means this is the resistive force, this is the applied force. 10 minus 6 will give you the net force 4 Newton that can be taken from MA, and you can calculate the acceleration of that body which is moving with this acceleration over there. After that, 10 and 6, So he is saying in the same direction they should be added over there, because vectors in same direction are always added. In case of this is 6 plus 5, 11 Newton should be subtracted from the right side of 7 Newton. So it is minus 4 Newton. Minus is here just to show the direction. It is not showing the negative magnitude of the force, because the magnitude of the force can never be negative number over there. After that, net force upward and downward is being taken, can be resolved into rectangular components by using the Pythagoras theorem. He has used hypotenuse square is equal to perpendicular square plus base square to calculate the net force over there when forces are acting along x-axis and y-axis. And 5 square plus 12 square, 144 plus 25 square root, that will equal to 169 square root, will give you the 13 Newton value over there. After that, he is saying resultant force is the combined effect of different forces acting on the body over there. So that is a resultant force. That is the combined effect of different forces acting on the body. Now he is talking about rate of change of momentum. As I said, F is equal to mv minus mu over t. He is again saying the rate of change of momentum. So F net is equal to mass into acceleration. Rate of change of momentum is directly proportional to the resultant. As he has removed this proportional sign to the equation formation, remember that 1 Newton force, 1 k Newton second, and 1 second is being taken to get a constant k equal to 1, and the equation has been formed over there. Resultant force directly proportional to acceleration, like F is equal to ma, which we have derived above, is being taken as our most important information, that resultant force is directly proportional to acceleration over there. After that, he is saying there that the motion is moving in this direction with this force. Net force F is equal to ma, deriving force minus resistive force is equal to accelerating force, and he has taken 400 mass is already given, and he wants to calculate the acceleration. Then he will use this relation over there. Again, F net is equal to ma. Then we can say 15,000 minus 8,000 again is equal to 400 into acceleration, and acceleration can be calculated. 200 Newton, 100 Newton, resultant force 100 Newton. So 200 is the winner side. Here it is only 100 Newton. This is the loser side. So resultant force with which the string is moving towards the winners is 100 Newton force. Signs of the resultant force, that they and their consequences. So I will say here that it will be 100 minus 200, then it will be minus 100 Newton, which is showing the left side direction of force. Direction of force over there. After that, rocket example is taken. There's a rocket is going in forward direction by cutting the drag force, and against the gravity he is working, and the thrust is provided in the form of explosion of the fuel material, that the fire is coming out back, and in that is action, that the fire is coming downward, and in reaction the rocket is going in upward direction over there. So both are going to happen in opposite direction over there, which shows that action has its equal in magnitude reaction, and which can be taken according to Newton's second law, and resultant force can be calculated. Like drag force is downward, gravity is downward, but thrust is upward. So upward minus minus. 20,000 minus 10,000 is 10,000. 10,000 minus 2,000 is 8,000 Newton is a force which is acting as an accelerating force, as a force with which the body is moving upward direction. And he said this is equal to accelerating force, and you want to calculate acceleration, then mass is given 5000 kg. So 8000 divided by 5000, three zeros gone, and it will be taken 8 over 5. Then 5 1 times 3, 1.6 meter per second square will be the acceleration that should be calculated by using the math relation over there. After that, Newton's third law, to every action there is an equal but opposite reaction. More detailed statement states that if a body A exerts a force on body B, and body B exerts the same force on A, which is equal in magnitude and opposite in direction, then this is called Newton's third law of motion. Remember that for the whole Newton third law to hold, there should be equal in magnitude, they should be in opposite direction, they should be of same type. Same type means it should not be like one gravitational, one electric force, or one magnetic force, like that should not be taken. They should be in the same type over there. After that, he is showing acting on different bodies. Means on one body there should be action, and there should be reaction on another body over there. Then we can say action and reaction are available equal in magnitude and opposite direction over there. Normal contact force is being taken. Weight is always acting downward, not low pair. Okay, normal act contact force, magnetic force, north pole, south pole, and voting reaction, action and reaction means a rocket is throwing out the burning fuel, and burning fuel in the response of action is showing the reaction that the rocket is going in forward direction over there. After that, he has shown over there little bit questions. Each diagram shows two forces that are equal in magnitude. Every diagram has also shows the two forces that are Newton's third law pair forces over there, named normal reaction, normal contact force, and weight. Normal contact force, book and table, friction, tension, block being pulled, and electron attracted towards nucleus, and nucleus is attracted toward nucleon. So action and reaction equal in magnitude and opposite in direction. In case of with which the force neutron, proton or nucleus is attracting an electron, electron is also exerting the same equal in magnitude forces on the nucleus, and both are balancing with each other over there. That should be taken that action and reaction have equal in magnitude but opposite in direction over there. Now he is moving towards the types of forces. Number one is friction. Whenever two forces slide over each other, there are contact points which slide over each other. And those contact points are called cold welds. And if two surfaces are sliding over each other, they have to face a resistive force, the force which keeps the stopping cause for motion to be available over there is called friction. It is a resistive force, opposing force which tends to slow down moving objects. If friction is not available on the surface of Earth, it will be impossible for any human to exist over there, and which tends to slow down moving objects. It acts opposite to the direction of motion. This is the contact free. This is the contact force and will not appear until the surface of the object do not produce a relative motion against one another over there. He has shown some cold welds. These are the contact points. These are the cold welds which are going to resist over each other to stop or to show the stopped resistive force. So this is the contact force will not appear until the surface of the object do not produce relative motion against one another. Until they are not going to slide over each other, the resistive force or frictional force will not be present. So what will be the benefits? What will be the disadvantages? They helps to walk. Without them, you can't walk. Helps to grip things. Helps to slow the things down. And disadvantages produces heat, which causes the loss of energy, wear and tear means broken down of the machinery parts over there, and efficiency decreases over there. So overall friction is in some cases beneficial and in some cases is not beneficial, and that is having some disadvantages over there. After that, methods to reduce friction. First of all, lubricate means use a smooth polished surface. Use lubricant or oil with the sliding parts. Use rollers to reduce friction over there. Means use the rolling friction. Use the tire to drive the car. Don't use the flat surface over there. If rolling is available, a very big object can easily be handled with the one person. For example, a big bed, or we can say a big heavy machinery present in a factory has a smaller wheels at its base over there, then those wheels can be responsible for rolling friction, and rolling friction cold welds can easily be very minimized if they are not having the wheels over there. That will be the sliding friction that will be much larger than the rolling friction. For example, you are driving car without your tires, then what will happen? A lot of friction from your engine should be exerted to even move a 1 meter or 2 meters over there without tires. But if tires are available and rolling friction is happening, a large distance can easily be taken into account. So use the lubricant, use the rollers to reduce the friction over there. Direction of friction on the wheel is shown. Push force and rolling torque. And friction is shown over there. Friction is available in the backward direction. And when rolling object, then the friction is shown towards the right. Due to the heat loss, energy is lost to the surrounding. So output is less, and hence the machine becomes less efficient over there. And one keep in mind one thing over there. There is no machinery, no generator, no motor is available with 100% efficiency. There is always decrease due to some heat loss, due to some other reasons over there. After that, circular motion. When a body moves on a circular path, then that body will show the circular motion. And circular motion is along a fixed point named as like center over there. Then in that case, if centripetal force is the force which keeps the body to move on a circular path. For example, there is a circular path, and this is the body which is revolving from the center around it by having the radius r. Then centripetal force will equal to mv square over r over there. M is the mass, v is the tangential velocity along the circular path, and r is the radius of that circle over there, on the circular path over there. Then this centripetal force formula is used. A force that causes an object to move on a circle about a point, and it is little given to force which causes the circular motion over there. For example, he is saying case number one, stone and string means you have fixed a string with a stone and you start to rotate in the form of a circular path that the stone is revolving around your hand over there. Then this, if there will be a tension in the string that will be responsible for centripetal force. Car making turned around a corner, there is a friction which is providing the centripetal force over there. Planetary motion, gravitational force. Electrons around the nucleus, electrostatic force. Unlike charges attract, and same charges, like charges, repel each other. After that, water in a rotating bucket can be taken into example. Direction of centripetal force, velocity, and centripetal acceleration. Centripetal force and centripetal acceleration acts towards the center of rotation. Velocity acts at tangent to the point on the circle over there, can be taken into account. So remember that this is your velocity direction over there. This is your acceleration, and force is given. So F is equal to mv square over r can be the formula for the calculation of centripetal force over there. After that, centripetal force is being shown that the force will always directed towards center. Force directed to center, directed to center, directed to center always. And the speed can be in tangential direction at any point over there. Center loving and attracted to the center means using the formula Fc is equal to mv square over r. And according to this formula, centripetal force will be directly proportional to mass. And heavier masses need more centripetal force. Like if you have increased the mass, then centripetal force will be much larger over there. Even though when we observe on motorway, why mostly the heavy vehicles like 24 टायर्स व्हीलर जो भी होता है, 24 22 व्हीलर्स, वो जो हैं वो इसीलिए क्योंकि सारे टायर्स के ऊपर फ्रिक्शन बैलेंस नहीं हो पाती, मोस्टली टर्न्स के ऊपर उलट जाते हैं. So the reason behind it can be taken in mind over there. After that, he is saying that centripetal force is directly proportional to velocity square. Speed, velocity, object moving faster need more centripetal force to stay in the circle over there. After that, it is inversely proportional to radius according to formula. So radius of circle to make a smaller circle, more centripetal force is needed over there. After that, free fall. Free fall is, for example, you were unfortunately riding a lift, and lift rope is broken, and now with the shooter speed you are falling under gravity. That is called free fall. Falling under the effect of gravity is called a falling due to weight over there is called free fall of objects. Free fall can be in air where no air resistance can be involved over there, and in vacuum no air resistance is available. So free fall in vacuum, due to the absence of air, no air resistance acts, only weight causes the object to accelerate, and hence the acceleration is equal to the gravitational acceleration, and no one can be taken into account over there. Both weight and heavy objects fall together. There is no way that you can prove that a small piece of paper is being thrown from top of the floor and on the other end a hammer is thrown. Both will reach to the surface of soil at the same time over there. Free fall in air. Air resistance is an opposing force which acts as opposite to the direction of motion over there. Air resistance increases as speed increases, and air resistance increases with surface area also. And when an object is released from rest, it accelerates due to gravity, and its initial acceleration is equal to the gravitational acceleration that can be taken as 9.81 meter per second square over there. As the speed of object is increases, air resistance also increases and eventually becomes equal to weight. So resultant force, and hence ac becomes equal to acceleration becomes equal to zero, and object reaches at rest over there. After that, terminal velocity is shown, and then parachute is coming down, and jump is taken. When he has taken the jump, no air resistance involved. A is equal to gravitational 9.81 should be maintained on Earth. And when your object of W is going upward and parachute is going to downward, weight is greater, and parachute is acceleration to find the parachute. So F net is equal to ma can be taken W minus AR, and we can easily calculate. AR is increases with speed, and WARF is equal to net A is equal to 0 can be taken into all the values over there. As persistence, as parachutist slows down, means when weight is equal to upthrust, then there will be a constant velocity attained by the parachutist with the opening of parachute over there. Then that is called that it decreases again and becomes equal to weight, and the parachutist will now fall at the lower terminal velocity with the constant speed over there. So in the end, he is talking about the gravity over there. What is meant by the term velocity? It is the rate of change of velocity over there. Explain why velocity changes. Because the direction of motion changes and the velocity in a vector is a vector. So it has a direction. So it is going to change. Explain what makes the satellites to move in an orbital path. Gravitational force. acts as a centripetal force which is directed towards the center of the earth over there, that is responsible for satellites to move on their circular paths over there. That provides earth provides the centripetal force. Then there is easy rocket example, and upthrust is added, and little bit more questions are added over there. All right. And draw the line between each bank. Yeah, that's easy one. Force A, force B, force C. According to the figure, we can easily explain car of mass. So overall, till here, I have talked about Newton's three laws. I have talked about the basic definitions of force, and we can say, uh, according to Newton's law, if I say define 1 Newton will be defined as 1 Newton can be defined as the force will be 1 Newton. Force will be 1 Newton if the force will be 1 Newton if 1 kg mass of a body, 1 kg mass of a body moves with if the force which will be 1 Newton if 1 kg mass of a body moves with um, an acceleration of 1 meter per second square over there. So force according to this, if I can say F is equal to ma, if 1 kg body is moving with 1 meter per second square, then 1 multiply 1 will give me 1 Newton force over there. After that, I talked about terminal velocity, I talked about upthrust, I talked about uh, the free fall case of objects over there. Then we can easily summarize that how they should be being treated in that case. So in the next section, we will go for density. We will go towards mass, weight, density, pressure, work energy, power. We will move towards them. That will also be the part of, we can say, the part of dynamics over there. In next class, we will observe that.